Find the number of polynomials having zeros as -2 and 5. Number of polynomials having zeros like this. The options are 1, 2, 3, and more than 3 polynomials. So first of all, let us find what is the polynomial having zeros as -2 and 5. So now it is like p of x equals x square minus alpha plus beta into x plus alpha. Beta is the required polynomial. Here alpha and beta are -2 and 5. So alpha plus beta is -2 plus 5, that is 3. And alpha beta is -2 into 5, that is -10. When we apply these values in this polynomial, what we get as p of x is x square minus 3x minus 10. So this is the polynomial with zeros -2 and 5. But we cannot strictly say that there is only one polynomial, because if we multiply this p of x by 2 or any other number, okay, for example, let us multiply this given polynomial by 2, then we get 2x square minus 6x minus 20. The zeros of this polynomial will also be -2 and 5. That means we can have a lot of polynomials having zeros -2 and 5. So here the answer is more than 3. This is the correct option. In the next question, p of x is given as a cubic polynomial x cubed plus bx squared plus cx plus d. If one of the zeros of this polynomial is 0, then find the product of the other two zeros. Okay, we know there are 3 zeros of the polynomial for this, because this is a cubic polynomial and normally we term it as alpha, beta, and gamma. So in the question it is given that one of the zeros of this polynomial is 0. One of the zeros is 0 means shall we take it as alpha? So alpha is taken as 0. When alpha is 0, and what is asked in the question, find the product of the other two zeros. Product of other two zeros means what we need is beta into gamma. This is what we need as the answer. And we know the relation between these 3 zeros, alpha plus beta plus gamma is -b by a, alpha beta plus beta gamma plus alpha gamma is c by a, and alpha beta gamma is -b by a. So from where we will get this beta into gamma? From this identity we will get beta into gamma. See, here we have beta into gamma, and what happens is alpha is given as 0. So this will become 0. That means 0 plus beta gamma is there plus alpha gamma. See, here also alpha is 0, so this is also 0, is equal to c by a. So actually this is asked in the question, beta gamma is c by a. This is the correct option, B. In this question, a cubic polynomial is given. P of x is x cubed plus ax squared plus bx plus c. If one of the zeros of this polynomial is -1, then find the product of the other two zeros. Okay, we have to find the product of two zeros. Anyways, this is the standard form of a cubic polynomial. In this given equation, in place of this a, we have 1. Okay, in place of a, we have 1. And in place of b, we have, here we have a. And in place of c, here we have b. And in place of d, here we have c. And normally we take alpha, beta, gamma are the zeros of this cubic polynomial. And in the question it is given that one of the zeros of this polynomial is -1. So let us take alpha as -1. Then alpha, beta, gamma. The product of 3 zeros, we know it is -d by a. And here alpha is -1. So we can give that -1 here. So beta gamma is equal to -d by a. Or in other words, we can say here on both sides of the equal to symbol we have a negative sign, so we can cancel them. So what we get is beta gamma is equal to d by a. This is what is asked in the question. This is what we have to find. Okay. And one more thing is given, P of minus 1 equal to 0, because minus 1 is a 0 of the polynomial. Then we can say P of minus 1 equal to 0, factor theorem, right? Minus 1 is a fact, minus 1 is one of the 0 means P of minus 1 is equal to 0. Okay, so let us give that minus 1 here. So P of minus 1 is minus 1 cube plus A into minus 1 square plus B into minus 1 plus C. This is given as 0. From here, we will get the relation between A, B and C. Minus 1 cube is minus 1. Then minus 1 square is positive 1. So this is plus A. Then minus 1 into B is minus B. Then plus C equal to 0. And see, in place of D, actually beta gamma, we got it as D by A. And in place of D here, we have C in this question. In place of D here, we have C. And in place of A, we have 1. So actually, beta gamma is, this beta gamma is, in place of D, we have C. And A is 1. So actually, we have to find the value of C in terms of A, B, right? So here, we will keep this A, B on one side and C on the other side. So we need actually C, right? Beta gamma is actually C itself. Okay, beta gamma is actually C itself. So here C will become 1 minus A plus B, right? We have to take this minus 1 to the other side. It will become positive 1. A to the other side minus A, minus B to the other side positive B. So 1 minus A plus B. So the correct option is this, option A. This is the next question. The zeros of x square plus 99x plus 127 are both positive, both negative, one positive and one negative, both equal. So without doing anything, we can find out the answer. Like we know alpha plus beta is minus B by A and alpha beta is C by A. And here in the given polynomial, in place of A we have 1, in place of B we have 99, and in place of C we have 127. So alpha plus beta will become minus 99 by 1, that is minus 99 itself, and alpha beta will become C by A, that is 127. So what we get is the product or alpha beta is negative and alpha beta is positive and alpha plus beta is negative, right? Alpha plus beta is negative and alpha beta is positive. This will happen only when alpha and beta both are negative. So the sum of two negative numbers is negative and the product of two negative numbers is positive. So both these zeros, that is alpha and beta, both are negative. So this is the correct answer, B. This is the next question. P of x is given as x squared plus kx plus k, where k is not equal to 0. The zeros of this quadratic polynomial cannot both be positive, cannot both be negative, are always unequal, are always equal. Here also, we will compare this to the standard quadratic equation. Then we get, in place of A, we have 1, in place of B, we have k, and in place of C, we have k, right? 1, k, k. And we know alpha plus beta equals minus B by A, that is minus k, right? B is k and A is 1. And alpha beta is C by A, that is k. C is k and A is 1. So what we know is the sum of two numbers is negative and product of two numbers is positive. This happens only when these two are negative, right? When two numbers are negative, the sum is negative and the product of two negative numbers is always positive. So the correct option is both cannot be positive, cannot both be positive. A is the correct option because when we add two positive numbers, it can never be a negative number. This is the next one. Ax square plus bx plus c, where a is not equal to 0. If the zeros of this quadratic polynomial are equal, then what is the relation between these a, b, and c? So zeros are equal means what? Discriminant is equal to 0. We know x equals minus b plus or minus root of b square minus 4ac divided by 2a is the root. Yeah, this will give us the roots. So if the roots are equal, roots are or zeros are equal means b square minus 4ac is equal to 0. So we will do from there b square minus 4ac equal to 0. And here that means b square is equal to 4ac, right? And b square of a number can never be negative. So the product of a and c is always positive. The product of a and c is always positive. That means both of them should be negative or both of them should be positive. Or in other words, c and a have the same sign. So this is the correct option, option C. This is the next one. X square plus ax plus b is given. If one of the zeros of this quadratic polynomial is the negative of the other, then it has no linear term and the constant term is negative. Has no linear term and the constant term is positive. Can have a linear term but the constant term is negative. Can have a linear term but the constant term is positive. Anyways, the question is about the linear term and constant term. Okay, so let us compare this with the standard quadratic equation. The standard form is ax square plus bx plus c. And here in place of a we have 1. In place of b have here we have a, and in place of c we have b. And one of the zeros is the negative of the other. So we know alpha, beta, conventionally they are the zeros, and one is the negative of the other means we can take alpha as negative beta. This is the given data. Alpha is negative beta. Then what happens? Alpha plus beta. One is the negative of the other means alpha plus beta will become minus beta plus beta, right? In place of alpha, we can give minus beta. So minus beta plus beta is equal to 0. That means sum of the zeros is 0. And we know alpha plus beta is normally it is minus b by a. And here in place of b we have a, and in place of a we have 1. So minus b by a will come minus a by 1, right? So minus a by 1 is alpha plus beta. And we know alpha plus beta here it is 0. Then what we can say? A is equal to 0 in the given equation. Because minus a by 1 is equal to 0 means a is equal to 0. Okay, the given expression is like this: x square plus ax plus b. Now a is 0 means what happens? This x square, a is 0 means that linear term is not there. A, in place of a we have 0. So next is only b. That means linear term is not there. And we have to find what about this b or constant term. For that, let us consider alpha into beta. Here what happens is in place of alpha we can give minus beta here also. So minus beta into beta, that is minus beta square. See, the product is always negative. The product of zeros is always negative because one is the negative of the other. And in this given expression or quadratic polynomial, alpha beta, we know it is c by a, and here in place of c we have b, and in place of a we have 1. So alpha beta is b. So what we can say? B is negative, right? Because alpha beta in this given expression b is, and alpha beta is negative means b is negative. So there is no linear term, right? As A is 0 and the constant term is negative. B is always negative. So the correct option is A. Has no linear term and the constant term is negative. This is the last question. Which of the following is not the graph of a quadratic polynomial? So we know from the graph we can understand the number of zeros for a polynomial, right? Here this graph does not touch the x-axis, means there is no zeros for this polynomial. This graph touches the x-axis at only one point, that means it has only one zeros of the polynomial. In this graph, it touches the x-axis at two different points, that means it has two zeros for this polynomial. And here in last D, option D, this graph crosses the x-axis at three different points, this one, and this one. That means this graph shows a polynomial having three zeros, right? So the question is, which is not a quadratic polynomial? Quadratic polynomial, we know maximum number of zeros is 2. So this can never be a quadratic polynomial as it has three zeros. So the option is D.